In the previous PowerPoint I introduced radians, so here's a quick starter just to remind you. There's a picture here with a sector in. I want you to find the area of the sector, and the information that you're given is that the perimeter is 14, so the perimeter of that red shape is 14. So pause the PowerPoint now and have a go at that question. On the next slide I'll go through the answer. Okay, so I'm going to go through the answer now. Press pause if you haven't had a go already. So we're told in this question that the perimeter is 14. Now the perimeter is made up of a 5 and a 5 and the arc AB. So the perimeter is when you add all the sides together. So there's a 5 for one of the radii, there's a 5 for the other radius. Now we're told that this equals 14, so 14 equals 5 add 5, add the arc from A to B. So obviously 5 add 5 is 10. Which means that the arc from A to B must equal 4. Now remember from last lesson from the last PowerPoint, so we had a formula for the arc. If you measure in radians, the arc length is radius times angle. So I now know that the radius times the angle has to equal 4. The radius is 5, so 5 theta must equal 4, so theta therefore must equal 4/5, or if you want to write that as a decimal, it would be 0.8 radians. Now in this PowerPoint I'm going to go through segments. Rather than sectors, like in that picture, we're going to now look at segments, which is a slightly different shape inside a circle. So just a reminder of the formulas from last lesson. Arc length is r theta, area of the sector is r squared theta over 2, and these only work if you're in radians. Now another reminder, a full circle, which is 360 degrees, is 2 pi if you're measuring in radians. So in this example, it says find the area of the shaded segment. So that shape there is a segment, the shape that's coloured in. The line from E to D is called a chord, but the shape that's coloured in is called a segment. Now the segment is part of the sector. I'm just going to outline in highlighter the full sector, and you can see that the green bit is part of that sector, but it doesn't include the shape that is a triangle. So if we find the area of the full sector and then we find the area of the triangle and subtract them, we're going to be left with the green bit that we want. So for the sector, remember there's a formula, r squared theta over 2. And in fact, I'm going to write that underneath the word sector, r squared theta over 2. And then for the triangle, there are a few different ways of finding the area of a triangle, but for this one, I'm going to use the half AB sine C formula, which is one that you would have learned at GCSE. So remember, the A and B are two sides, and C is the angle between them. So I can use the 5 and the 5 as the two sides, and then the angle between them is the 1.3 radians. So if I put in all my information then, r is 5, so that's 5 squared. The angle is 1.3 over 2. And then for the triangle, A and B are the sides 5 and 5. And then C has to be the angle between them, which is 1.3. Now to get the correct answer for this, I need to make sure I'm in radian mode. So on the class whiz, I need to press shift and menu. And then I need to go into number 2, which is the angle unit. I'm going to select number 2, which is radian mode. So now I'm just going to type all of that in on the calculator. 5 squared times 1.3 over 2. That bit is 16.25. And then a half times 5 times 5 times sine of 1.3 is 12.04447732. So if I do 16.25 minus that answer, it gives me an answer of 4 and I'm going to round now to one decimal place. It would be 4.2 if I rounded it. And it's an area, so my units would be centimetres squared. Here's another example that I've taken from the booklet. It's very similar, so we're finding the area of the shaded segment. So you can see in the answers, they found the area of the sector and they've taken away the triangle. We've done it by using a little bit of factorising there, but I would just do area of the sector, take away the area of the triangle. So back to the exercise on page 7, question 1. If you look at D, E and F, on those ones that you're asked to find the area of a shaded segment, so you can have go 1, D, E and F. Question 7 is another nice question if you want to have a go at that, but anything from that page would all be good practice. And then on pages 8 and 9 you've got some past paper questions, so I recommend that you have a go of those. The mark schemes are also in your booklet, so you can check your answers to the past paper questions. Here's another past paper question that isn't in your booklet, which I'm going to go through now. This one says the diagram shows 4 points P, Q, R and S on a circle with a centre O and a radius of 13 centimetres. The line from Q to S is a diameter of the circle, and then they've labelled two different angles. POQ is called theta and QOR is called phi, different Greek letter there, phi. In question A, the area of the sector POQ is 60. So I'm going to colour that in. So POQ, P to Q, so that sector there has an area of 60, and it's asking us to find the value of theta, given our answer correct at 2 decimal places. So there's a formula for area of sector, which remember you need to memorise, r squared theta over 2. They tell us that it's 60, and we also know that r is 13. So rearranging that, I need to do 60 times 2, and then divide it by 13 squared. And theta turns out to be 0.71 if you round it to 2 decimal places. So that's part A. Now part B is a little bit more complicated. I think that the way that part B is worded is a little bit more complicated. So it says the length of the arc QR, so from Q to R, that arc around there, is 7 centimetres greater than the length of the arc RS, which is that one there, the blue one. Find the value of phi, given your answer correct to 2 decimal places. So what I'm going to do is I'm going to write down this sentence, but instead of in words, I'm going to write it down in symbols. So it's telling me that the green bit is 7 centimetres greater than the blue bit. So what that tells me is that if I started with the blue bit and I added 7, that would be the same as the green bit. Okay, because the blue one, add 7 is the green one, because the green one is 7 greater than the blue one. Now, let's think about how we could write down these arc lengths. Well, the green one, remember there's a formula for arc length. The arc length formula is radius times angle. Now your angle is not always called theta. For the green arc, the angle is actually called phi. Okay, but the formula is radius times angle, so for that green part, it's radius times phi. So I could put that in for the green part, radius times phi. Now I need to figure out this green part, this blue part. So the blue arc, the formula is radius times angle. Now unfortunately that angle is not labelled. Now what I don't want to do is introduce a brand new letter, because if I introduce another new letter, it's going to overcomplicate things. So I'm going to try and write down what that angle is using letters that are already used in this question. Now can you see that in this picture we've got a half a circle, and half of a circle when you're measuring in radians is pi. So if I took the phi away from the half a circle, it would give me this little angle that I want. So this little angle in here is going to be pi take away phi. It's like doing 180 degrees take away the angle that you're given in the question. But instead of 180, I'm going to write pi because I'm working in radians. So this arc length, this blue bit, is radius times angle. So it's radius times pi minus phi. So putting all that together now, I've got the blue arc length, add 7, equals the green arc length. I can put r in. I could have put r in already if I wanted to. R is 13. And now I've got an equation with just one unknown. The only unknown there is the phi, so now I can solve it. So I could expand the bracket, 13 pi minus 13 phi plus 7 equals 13 phi. I could now move these phi's over to the right hand side. So I get 13 pi plus 7 equals 26 phi. And then finally, if I divide by 26, then I can get phi on its own. So on the calculator, I'm going to type that fraction in. 13 pi plus 7 divided by 26. And phi turns out to be about 1.84. Remember it asks for 2 decimal places, so you've got to get the correct number of decimal places. And it's an angle, so I'm going to write the little c for radians.